Welcome to the talk in Bachelor of Engineering in Mechatronics System. These talks will describe a multidisciplinary and integrative applied learning program in Mechatronics System. I'm Dr. Pao from SIT, and with me is Dr. Tang Liang from DigiPen Institute of Technology, Singapore. Together, we will present this talk. Here are the outlines for the talk. First of all, we'll give you introductions what Mechatronics Systems is about, followed by a brief to the program background, and what is the learning pedagogy applied in this program, and subsequently, we'll provide some highlight of these unique features in this program, as well as what are the career opportunities that the graduate from this program can look forward to. And lastly, we'll conclude off with these admission requirements to the program. So what is Mechatronics Systems? So this engineering program, we look at the Mechatronics system. Note that the Mechatronics, there's an S there, and the system, there's an S there. So this represents, there are two fields of studies in this program. Firstly is in the mechatronics engineering, and secondly is in the system engineering. Mechatronics engineering is a multidisciplinary field that combines the electrical, electronics, mechanical, and software engineering within this system. Whereas system engineering focuses on the engineering management in the design, integrations, and management of the system over its entire product life cycle. So what is the roles of mechatronics systems in our current and future economy? With the rapid transformations of the industry, whether in terms of digitalizations, Industry 4.0, or the use of robotics systems, we need the field of this multidisciplinary mechatronics knowledge in order to come up with innovative solutions for our transforming industry. Apart from that, we need the knowledge in system engineering to manage the design, integrations, and the product lifecycle management in coming up with these innovative solutions for the industry. So what is this program in Mechatronics Systems is about? So the degree in Bachelor of Engineering in Mechatronics System, previously known as SIMS, which is System Engineering in Electromechanical Design, is set up so that it can nurture individuals to excel in the mechatronics system field of engineering, so that they can tackle the challenging problems in the industry due to these transformations. We want our graduates to have 4 attributes. Firstly is in terms of their technical competency. They will have the mechatronics technical skill sets and the system engineering management skill to come up with the solutions for the industry. Secondly, we want our graduates to have innovative, creative thinking so that they can provide innovative solutions for the transforming industry. Thirdly, we want our graduates to use their project management skills that have acquired in the program, whether they are working as a team or they are the leaders in the team in delivering these system solutions. And lastly, we want our graduates to have professional responsibilities in terms of staying grounded and serving the community with integrity. Next, I'll hand over to Dr. Tang Liang to give you more insight to the program.
Thanks for the Dr. Paul's introduction. I'd like to share program background here. This program is a joint program between DigiPen and SIT. It was launched in September 2015, and it was called Systems Engineering on Electromechanical System, or SIMS. It has been renamed to Mechatronics Systems because we believe it can represent the teaching and the student outcome more accurate. The teaching staff are from SIT and DigiPen. SIT staff are more focused on mechatronics and system engineering, and the DigiPen staff are more focused on electronics, electrical, and software engineering. The faculty members from both sides, they have intensive academic and industry experience. Maybe you are not familiar with DigiPen. I'd like to share with you. So DigiPen is a specialized university for the digital economic with a focus on computer science, embedded system engineering, user experience and user interface design, digital art, and animation. DigiPen is highly ranked by Princeton Review. It was ranked among top 5 game design schools in 2020. Let's have a look at the numbers so that you can have a better overview. So for the DigiPen, the annual students intake is more than 270, and the enrolled students is more than 1,000, and the student to staff ratio is 16 to 1, and totally there are more than 1,000 graduates, and there are more than 150 employing companies. Let's have a look at the milestones of DigiPen. DigiPen, it was founded by Claude Camille in Vancouver, Canada in 1998. DigiPen moved to Seattle in 1998, and it was the first game design school in the world. In 2008, DigiPen opened the first overseas campus in Singapore with the invitation from EDB. In 2010, DigiPen entered the collaboration with SIT. Then over the world, there are 3 campuses. So the main campus is in Redmond. And here is the Singapore campus. And we have another campus in Bilbao, Spain. DigiPen is different with many other universities in teaching. So first, we focus on academic foundation. So we want students to learn how to use a tool, but also we also want to let students to know how to make a tool. And we also focus on applied learning, and many project modules are provided so that the student can apply the theories they have learned from various modules and to build the projects there. And we also focus on industry collaboration. So we give opportunities to the students to work with the industry partners so that the students can know what is required from the industry so that they can be industry ready. Let's have a look at the program curriculum. So totally there are 4 years for this program, and each year there are 3 trimesters, except the last year. The first year, we will help the students to build the foundations. The second year courses are the core modules. In the third year, the students will work with the industry partners through the IWSP program. In the year 4, students will come back to campus to learn the advanced module and complete the program. Here is the program curriculum design. So we provide the modules under the basic engineering and the communication. So this provides the foundation to the students. Then we provide the multidisciplinary domain modules. So for example, software engineering, electrical engineering, mechanical engineering, system engineering. So after that, we provide the project modules and the IWSP so that the students can apply this kind of theories through the projects. This program is accredited by the Institution Engineer Singapore and the ACCSC. Then let's have a look at the curriculum composition. So totally in this program, there are 42 modules. The majority is in the mechatronics related domain, so which contributes 33%. The next is engineering foundation, which occupies 21%. Then the system engineering occupies 19%. Then for the remaining, the project modules and the others and the IWSP. Next, I'd like to invite Dr. Paul to introduce the learning pedagogy.
SIT is a university of applied learning. And in this program, we adopt an applied learning pedagogy approach. Here, I'll describe the multidisciplinary and integrative applied learning approach that's adopted in this program. First, in the area of multidisciplinary learning, we equip our students with the knowledge of this mechatronics engineering, making up the fundamental in mechanical engineering, electrical engineering, electronics engineering, and software engineering. With that, we fuse together the other field of study in system engineering. So how do we actually do that? We encapsulate system engineering modules within the curriculum following the INCOSE system engineering framework. INCOSE represents the International Councils of System Engineering. So with this framework and with the modules within the program, we actually impart the system engineering body of knowledge to the student in the curriculum itself. So in the applied learning, we make use of different project-based applied learning teams. And the motivations of putting these project-based modules is for us to let the student apply the knowledge. Secondly, they learn through doing in the project, and also they work as a team to deliver solutions for the project. Working as a team is a very important knowledge and skills the students have to learn during the program, since system engineering is actually a team-based activities. So in general, there are 4 teams that are being used. Firstly is the modules common project team, followed by system engineering projects in first 2 years of study. And the third year, we have our integrated work study program. And finally, we have the capstone project in their year 4. So I'll describe the first 2, the modules common project teams and the system engineering projects. So first, on the module common projects teams. So this project team is for the students to apply their multidisciplinary mechatronics engineering skills that they acquire in their modules. Here, what we have is a common project or common platform that is used amongst all the modules. And in this case, for the track platform, we have the modules in computer-aided design, where students learn and apply their knowledge on how to design the mechanical components for this track platform. Subsequently, with their design, they perform engineering fabrications to fabricate the parts that are required for this platform, whether it be it in terms of 3D printing or machining. And in the computer environment modules, they put in electronics and also perform software programming so that they can make the entire integrated track platform system to perform autonomous navigation missions. So through the use of these common platform or common project teams among different modules, we are able to let the student apply this multidisciplinary mechatronics skills and knowledge during their curriculums. Next, I'll talk about this system engineering projects team. So apart from applying the mechatronics engineering knowledge, the system engineering projects teams allow the students to apply their system engineering management knowledge and skill sets. This is done through using complex projects problem that is posted to the students so that during the project, students can apply the knowledge that they gain during the current modules they are taking, as well as these, by going through the complex engineering problems, they can acquire this prior experience before they take on the advanced module. In doing that, we allow students to appreciate these problems with the complex engineering, and it helps them in the advanced module studies. So these slides show examples of this scenario that is being posted for this system engineering project. Here we have a humanitarian disaster relief missions where the students are tasked for the missions to come out to develop solutions for a quick airborne deployable small ground robots so that this can go into the buildings to do search and rescue missions at the affected area. So through the use of system engineering knowledge, the complex problem, right, is broken down into simpler problem through different projects. The first project will focus on the platform, system developments and integrations, while the second project will focus on the conceptual or preliminary design of a payload system that's supposed to go onto the robot system, while the third project modules will need to put together the entire system as an integrated complex system so that it can deliver these robots through airborne means to the affected area. And at the same time, they are supposed to derive the concept of operations to make the entire mission successful. So through the system engineering projects and working on complex engineering problems, we are able to let the students apply the knowledge in system engineering in designing, integrating, and managing these system developments through the life cycle of the project itself. Next, I'll share videos on these applications of this learning in mechatronics systems, how the students are able to put their knowledge together and deriving solutions for these project problems.
I'd like to share the program highlights. So there are 3 highlights here. The first one is the OIP, or Overseas Immersion Program. The next one is the IWSP, or Integrated Work Study Program. And the last one is the capstone projects. So first, let's have a look at the OIP. Students need to study 1 trimester in Redmond, Washington State, in the United States. So there are 12 weeks there, and the students need to learn 5 modules. This OIP gives students international exposure and cross-cultural awareness. Redmond is a beautiful place. So you can see many sightseeing places, such as Mount Rainier, and you can see the first Starbucks coffee shop. And you can see many technology companies there. For example, Amazon, Dropbox, Microsoft. Next, I'd like to share the IWSP. Students need to study 8 to 12 months with companies, and they have the pay. And this opportunity can let the students to apply what they have learned from school to the real project that they have received in the industry, and so that they can develop their skill set, which is needed in the industry. And more important thing is we give this exposure to the students, so the students usually they can secure their job through this IWSP opportunity. Then let's have a look at the capstone, or the industry capstone. Because this capstone usually it is from the IWSP, and which is from the industry. The students can develop their skill here and apply what they have learned from the school and what they have learned from the IWSP, and this time they are the owner to build this project. So this project is a team-based project. Students they need to propose the project by themselves. This one is different with the IWSP, where the tasks are given from the industry. And finally, students need to give the project outcome to the industry. So here is one example of the capstone project demonstration. A set of sensors are attached to a user's arm, and the user's operation can be captured. So this kind of motion data can be transferred to a robotic arm, which can be used in some dangerous environment, such as radiation environment. So currently, A-STAR is working with our students to apply this project. Next, let's have a look at the job opportunities. The first, the students' job opportunities are abroad. So you can see students, they can choose many different areas. For example, system engineer, project engineer, software engineer. Then second, there are many different companies. They are looking for our students. Right now, we have 2 graduation cohorts. Based on the feedback, our students, they are very well welcomed in the industry, and the pay is good. Then let's have a look at the admission requirements. So for the admission requirement, so at first, we welcome the students from the poly, if you have a poly diploma. So the evaluation is in a holistic method, and the module examinations is based on a case-by-case the situation. So we also welcome the students from with the A-level result or the IB diploma. So as long as you pass one of the following H2, so in mathematics, physics, or computing, or H1 mathematics, or if you pass in HL subjects such as mathematics, physics, or computing, or SL mathematics. We have a virtual preview day on 30th January 2021. Please scan this QR code so that you can hear the talk from the school founder, and you have opportunity to talk to the faculty members. Thank you. See you on the preview day.